Okay, there's a couple of small issues I'd like to address as far as these headstock goes. One of them, when the lathe's in gear, either low gear or high gear, I like to be able to just flip it into neutral and easily turn the spindle. Now sometimes the real juggle just doesn't want it, just wants to go between one and the other. It can be a real headache to get it in neutral, it's not an easy thing. So I want to see if it has the capability for us to drill an extra detent in the lever. The other one is the speed control here. This is not really positive. There's a detent there, but I want to see if we can adjust it and make it feel a bit more positive. You know, it's quite good now the lathe's cold, but some days you're not sure if you're quite in gear, so we'd like to improve on that. As far as the rest of it goes, the rest is fine. And the other issue which we need to deal with is inside the change gear housing, so we'll pop the cover off and give you a look at that one. Okay, so the other issue I have here in this lathe is we have our drive belt here, and every time we need to change to the slow speed pulley, this belt has to come through this gap here, and as you can see the belt's twice the width of the gap, which makes it a bit of a mission every time. It's not a quick job. You've got to sort of struggle to get the belt over the top of that pulley through this gap here and onto this pulley here. Now I don't know if this is the same, if it's just something with this lathe or the other models in some of your other countries. There's a lot of these lathes out in the US market, whether you guys have this issue or things are set up different there. So what I think I'm going to do to correct this issue, I'll swing you around for a better view. Okay, one option open to us to alleviate the problem of the belt clearance is to space the entire gear train out 1/4 of an inch, 6mm. But there is another option we might look at, because that way would involve making a lot of spaces and things like that. If we look at down here, we've got clearance behind the pulley on the motor, so the pulley can go in towards the motor further down there, and we've got clearance behind the pulley there. So we might be able to do something in that avenue, but just there there's a cap screw for the belt adjuster, which is also tight up against the pulley, so we've just got to be careful we don't block our clearance off for that. So we might look at the pulley option first, as I think it'll be a lot easier to do it that way than machine up a heap of spaces for the gear train, which we could run into trouble down here where the banjo goes on. So we'll get the pulleys off and have a look. Okay, we've put our offset in the adjuster bar down to the motor, just there. So we've picked up our 3mm or 1/8 of an inch there. So what we do now is we'll refit the pulley and get a measurement of how far the pulley can come back. Refit the pulley up against the shoulder. So if I sight down now, there's the torch. We've got 6mm of clearance there now. So if I take off 4mm off the back of the pulley, off this face here, that should alleviate some of our problems, and we'll refit the belt, refit the gear, and see how it goes. Okay, we're just going to set the pulley up in this chuck here, just to take our 4mm off, or we'll just take 155 thou off, that's close enough. So this chuck, it's a bit of an unusual one. It's like a faceplate with jaws, so we operate the jaws as usual, you know, in the normal fashion with the key in the top, but there's also a nut, a locking nut behind it, which pulls the jaw in and locks the jaw in position. So I'm not quite sure the make of it. I don't know. It's, as far as I know, it's always been with this lathe since I can remember. So, and it's called well, I've been told it's called a 4-jaw continental chuck. So we'll get our part put in. It doesn't have to be absolutely perfect, but as close as we can get it would be good. I keep forgetting because the jaws operate the opposite way to a normal chuck. Okay, it's clocked in that way. So we have these lock nuts to nip up at the back. Okay, we're within a thou that way, that's fine. So we'll just check the face, the run out on the face. And we're within a thou that way. So that's good. Now, a little bit of Scotch Brite, just polish up the compound slide knob so I can read the graduations. $70, $80, $90. So 100 thou per revolution, we want 155 thou. So. Okay. Okay, so now it should just be a simple matter. We reinstall a keyway in the input drive shaft. Our pulley goes back on. Now I did have to fit a washer because the end of the shaft sticks further through the pulley now, and that part of the shaft isn't threaded. So the washer goes up, sits on the plain part of the shaft. So we just nip out a nut up. Okay, now we'll put our change gear back in. Okay, so have we achieved enough clearance? Oh, look at that. We've just got that. Okay, so all I have to do now is just adjust the motor pulley in till we get our belt alignment back up again, and that problem's solved. Okay, the next stage is really to set the backlash on our gears here, but before we do that, we'll get the oil change completed in the headstock, because the drain plug to get access to it is behind this gear. We slip our gear back off. Now, just there is the plug for the oil for the headstock. We crack him off. And of course, have a drain tray ready. So, the best drain trays are in the kitchen cupboard when the wife's not looking. We'll let it all drain out and try and catch most of it. We'll quickly put the plug back in. Go and empty my bowl and come back. Okay, so while the oil's draining, we just plucked off the lid. Now, there's this channel running all the way around it. So, oil gets splash fed from the gears and thrown up into these channels. So, and then what I thought were lubrication passages down to the bearings, these holes here, actually just go nowhere. They just come back down into the inside of the bearing. So this bearing's just lubricated by the oil splashing around, so that does nothing, as does the one, there's a port in the front here, that does nothing, absolutely bugger all. But there is a very small one here next to it, that small hole there, I suspect that does go down into the bearing. So what happens here though, you see debris on either side of the hole, so that's all crap that needs to be cleaned out, as is, if we look down the bottom, you see the metal down in the bottom. It's hard to get a good shot down on that side, but anyway, all that material, all that metal down the bottom, we've got to flush all that out. So we'll get that flushed out and then bring you back. Okay, we've cleaned out our headstock as best we can. Now down the bottom, just there, we've just got a rare earth magnet sitting there to collect the debris from the bottom. Now if we put that flat on the bottom, we'll never get it back out. So at least we can pluck that out with a pair of pliers. And we've also put magnets over the oil galleries hidden near the bearings front and rear, because there's a hollow under these with like a collection point where the crap ends up. Now the reason why you get so much crap in these blades is these all the gears, they're all non-hardened gears, they're all as soft as, so nothing's hardened in here at all. So the magnets should help with that. So we'll get the lid back on and we'll move on with our detent adjustment. Actually, we'll do that before we put the lid on, I think. So now to access the detent adjusters, these two stickers here have to be removed. Once they're removed, I doubt seriously they'll go back on. So we'll see how we go. Okay, so what these guys have done, just here are the drillings for the two indents for the ball to go into for the high and low speeds. Now I was hoping to drill another one in the middle, but these are two right next to each other. So I'm going to drill another one over to the side here. So what I'll do is I'll drill through the lever, reassemble the lever, and then spot through into the casting here with the drill and fit a grub screw spring, and we use the spare ball that we found from here. We'll put it in up here. That'll give us our third location, our neutral position. Okay, we ended up pulling the sticker off, so that came off relatively easy, so we didn't drill a hole through it. It was only held on with rice glue, so it flipped off quite easy. So what we've done, we've drilled and tapped an extra hole on the side. So we have a grub screw, a spring and a ball, and then we drilled through and indented into the headstock casting, the drilling for the ball to seat into. So that gives us our neutral position. So that's the neutral there. So we go low range, neutral, high range, back in the neutral. So I find it's handy to have a neutral position, especially when you're setting up a forge or chuck or something. Makes it easier to turn the spindle. So what we're going to do, I'll pop this cover off so we can get better access to see what we're going to do in the quick change gearbox. Now this sticker here has to also come off, just so I can make the adjustment to the detent screw on this other speed control lever. The second speed, it's a bit wishy-washy where it goes in, so we can just tighten up that adjuster. So I'll have to flick the other sticker off to do that. We've just got a craft blade, craft knife. We'll just work our way through. Whoop. And it comes off. Good old rice glue. Okay, so our ball and detent for this one are just in here. It's just a matter of tensioning up the grub screw a bit more, so you get a bit more positive feel. Even still, it is quite wishy-washy. There must be a lot of play in the hole. I do prefer to have them a little bit firmer, so that's about as good as we're going to get that one. So I'll pop these levers off and pull the cover off, and then we can see what's going on with this feed box. Make sure we don't lose all our springs and balls. 1, 2. Back this adjuster off. We can adjust this up easy enough later on. This one's got 2 balls in it as well. Interesting. Okay, so off with our cover. I'm only taking this off because it's too hard to see what's going on with this ridiculous oil system in the quick change gearbox. Okay, so our cover comes off. And then what we're left with is this cover plate here. Now our oil filler for the gearbox is a plug in the front here, so I'll give you a shot of that. Okay, that little rubber plug there marked oil, you pop that plug out and that's where you squirt the oil to lubricate the quick change gearbox. Now this plate, so we pull out our filler plug out, this plate slips out, so the oil from the filler plug goes through that hole and just comes out there and goes down. There's a cloth in here which sort of keeps the oil soaked up a bit. It's a pretty ridiculous idea. Now there's a row of holes along here, you might just be able to pick them up, all these little drillings. So when the oil squirted into this hole, it's supposed to settle onto that bit of cloth and go down all of these drillings, which it doesn't. Up the back there's just bone dry. Because the casting's not flat, the casting actually sits on an angle, it's cast on an angle, so all the oil mainly pulls in this front area here and bugger all goes up the back. Now one of these little drillings goes into a copper tube inside which lubricates one of the idler gears inside. So I'll show you what's going on here. So I've been thinking, how can I improve the goings on there, and it's I think I've come up with a solution. We'll pull this off and we'll okay, so this cover just slips off. Just on dowels, a couple of dowels, and that's your adjuster, your mechanism for engaging either lead screw or feed shaft, just there. We'll get that out of the way. Now, when you go to lubricate all this, oh, that's that tube I was talking about. So that comes right down underneath and goes to a bearing on the end of the feed shaft gear. Okay, so my plan was to get rid of that cloth that they had. So I've got now a series of wicks going down every oil hole. So if there's only oil at one end of this collection area, the oil will still travel along the wicks. So I'll get you a shot looking underneath this plate. Okay, there's a shot here, so we've got all the wicks poking through. There, up there and up there, so they'll dribble the oil down onto the gears, and there's also one going down to this tube. So what I was finding before, we'd went through the filler port here with the original system, we'd pump this full of oil, and most of the oil would just run down the holes that were up this end and straight down into the tray at the bottom, and bugger all was actually getting up to this end for these gears here. So we'll put some, we'll prime it up with some oil. We'll just see how the system works. Okay, this explains the scenario that was happening really well. So we've filled up our oil cavity, and so that's filled to overflowing down this end. We go up the other end, and it's dry. So over a period of time, these wicks will suck up the oil from down this end and transfer it up to this end. Now that's as much oil as you can get, otherwise it starts overflowing, just running out the front of the machine, which is totally stupid. So you can see it's starting to drip through now. And the added advantage too with the wicks going through the holes is it does slow down the rate of oil that is dripping through. So okay, so we've put a bead of that red Celastic on the front of the housing there. That way we can get full coverage of oil in the tray, and it will also hold a bit more oil. Now we'll get you a shot of the dripping action underneath. Okay, so we have a bit more controlled drip. So the holes that were gushers, I've just stuffed a bit more of the wick in, and now we just have a slow controlled drip feed down to the gears. Okay, we're just ready to put the lid back on the headstock. So all we do here is just a tiny smear of Celastic around it just to seal it up, and the 4 screws to bolt her on. Okay, so we have to refit our oil drain plug. So I'll just put a bit of Loctite pipe sealant on the plug. Doesn't need much, just a bit of a smear around. Butterfingers. Okay, so we'll top up the oil. Goes in the little filler port at the top there on the lid. So the oil that I use in all my headstocks and feed gearboxes is 68 grade hydraulic oil. So we'll get her put in. So we just slowly fill her up. She's coming up on the sight glass now. Till we're at the high mark, which is there. Okay, and now we'll fit our idler gear back onto the banjo and adjust up the backlash. Just sitting in by hand. check it in a couple of different spots. Okay, that one's feeling good. Now we go from the idler gear to the input gear of the lathe. This one needs adjusting up, which is a little bit too much backlash in that one. So we adjust the banjo to take out the backlash there. We have a different spots. Takes a couple of goes to get it right sometimes, but it's okay. That's good there. We'll nip up the banjo. Now to lubricate these gears, I normally just run a bit of grease on them. Oil tends to fly around everywhere, so that's what you don't get your fingers stuck in it. That's all it needs. Okay, so I think we'll pop the cover on and give it a test run. Okay, one job I did have to do was to time the threading indicator so the numbers line up with the indicator pointer there. And that's just a simple job of slackening off. There's a cap screw underneath that secures the bronze gear, which picks up off your lead screw. So you slacken that off. Then with your half nuts engaged, you just move the dial around by hand until the number lines up and then nip up the indicator. So if I disengage our threading, the number comes around, so the number comes around when the number's at the edge of the rivet. I engage, I feel the crest of the lead screw engage with the half nuts and then it drops in. Bring you around to the lever. So we're coming up on a number. On the crest, then it drops in. Coming up to our mark on the crest, then it drops in. Now, if you're cutting metric threads on an imperial lathe, like this is an imperial lead screw lathe, just a quick tip. Coming up, okay, you're threading. Got to the end of the thread, you can disengage the lead screw, turn the lathe off, reverse the lathe, come back to your original number, pick up that number again. reverse your tool back out to the start of the cut, turn the lathe off, reverse, change direction into your normal rotation, you take another cut until you get to the end of your thread, disengage the lead screw, reverse the lathe, and pick up on that same number again. That's it there. So that's how you can cut a metric thread on an imperial lead screw lathe and still disengage the lead screw. So anyway, we've got the tailstock to go. I did a couple of preliminary measurements of the quill of the tailstock regards to how it runs on its axis vertically and also on the horizontal plane. And quite frankly, I was shocked. So if you want to see something shocking, watch the next episode when I get involved with the tailstock. That'll wrap this one up for now. So apart from a couple of minor details like the oilers and a couple of bits on the compound slide, which I'll catch up with later on, this is probably as far as we're going to go with this lathe repair at the moment. So we'll just do the tailstock and we'll hook back into some machining again, and so I have a heap of tooling to make up for the Bridgeport.